Good day. We're looking at qualitative analysis. In chemistry, there's all kinds of qualitative analysis. And all that means is we're trying to identify things like a chemical in a sample, but we don't care about the amount. If we cared about the amount, like if you're testing for blood alcohol, where you have the 0.08, that would be quantitative analysis. But qualitative analysis might mean we're looking at a sample of water and we want to know, is there lead in there? Is there copper in there? Is there mercury in there? That would be qualitative. So there's all kinds of ways that qualitative analysis can be done. But in this section, we are looking at solubility, whether things dissolve or not. So there we are, qualitative, identifying a substance. And quantitative analysis is saying how much of that substance is present in a sample. So this is what labs will often be doing. And there's our breathalyzer. So you've done some qualitative analysis in the past with litmus paper, lime water, and assorted flame tests. And, well, I guess you didn't get a chance to do flame tests last year, but c'est la vie. So here we are looking at taking a mixture and pulling the ions out one by one. That means you need this friend nearby, your table of solubilities. So what we're looking for is we have sulfate and chloride, and we want to pull them out one by one. So somewhere I see sulfate here and I see chloride here. And it means I'm going to have to add a cation. The first step is to add a cation that will precipitate out one without the other. Now you might say, oh, what if I add silver? No good. Silver will precipitate out chloride. Silver will precipitate out sulfate. So you end up with a big precipitate that's a mixture of both things. You haven't done it one by one. Same problem for lead 2+. Now you might say copper 1+ would work, and that's true. But let's try a slightly different example. It says all others. Well, you know what? If I chose something like calcium, I would get calcium sulfate, low solubility. That would precipitate. But calcium is soluble with chloride. So calcium would work and strontium would work quite nicely. So when I add calcium ions, I have to add in the form of a soluble calcium salt. I just can't find calcium ions on a shelf. So I'm going to grab it in the form of calcium nitrate. So you got to copy all this out. Because I know nitrates are always soluble. So it'll go into the water and it'll split and I'll have my calcium ions. And now I can do my net ionic equation for it. And that will precipitate out the calcium sulfate, and there's my net ionic equation. And then I would filter it. Now at some point I'll try to do an actual sketch trying to illustrate what's going on. Calcium chloride didn't precipitate out, it's soluble, so I can filter. And when I filter, the calcium sulfate is now removed. It'll sit in the filter paper. The calcium chloride is still soluble. It passes through the filter paper and is called the filtrate. So now I can add anything that's going after chloride. But if I started with the chloride, to pull the chloride out first, you can see this is where I could use the copper 1+. Because copper 1+ will pull out the chloride. Copper 1+ fits in this category of all others where it's soluble, so it will not precipitate out the calcium sulfate. So I'm going to show it in the same way. I add copper 1 ions in the form of copper 1 nitrate, CuNO3. I precipitate it out, it goes boom, boom, boom. CuCl is a solid, and I could filter it out, and it would leave behind, in this case, the sulfate. Now typically that's not exactly how we do the question. Normally it gets easier as we go along, because once you take out one ion, you don't have to worry about it again. It's gone. And then you can go after the next one. So we want to precipitate out one ion at a time. In this case we had negative ions, so we had to add positive ions, which are called cations, to do that. And for us, this is called selective precipitation, That's the kind of qualitative analysis we're going to do. I'm going to stop here and we'll carry on with the notes in part 2 of this video.